Hi guys, so here is the pre-calc review. For number 1 here, we have a bathtub was partially filled with hot water when the cold water tab was opened. 2 minutes later, the bathtub held a total of 48 gallons. 5 minutes after turning on the cold water, the bathtub held 61.5 gallons of water. So if we make a function gallons to time, we know based on the problem statement that g of 2, when t is equal to 2 minutes, is 48 gallons, and g of 5 is 61.5 gallons. So for part A, what was the rate of change in number n gallons from 2 minutes to 5 minutes? We're just going to use our rate of change formula. So y2 minus y1 divided by x2 minus x1, which then gets you 61.5 minus 48 divided by 5 minus 2, which you can put into your calculator, and you get that it's equal to 4.5, then gallons per minute. So now for part B, how much water was in the tub at the time the cold water was turned on. We know that 4.5 gallons per minute is the rate at which the water is going in, and we know at 2 minutes it's 48. So what we're going to do is we're going to do 48 minus the 2 minutes times the rate of water which is going in, which gets us 39 gallons. We now have all the things we need to write a linear function. So we know, based on our last one, that g of 0 is equal to 39 gallons. And it actually wants us to use n number of gallons. So we're going to change what variable here, and we're going to write n of t is equal to, and we know the formula mx plus b for a linear function. Our m is going to be our slope, which we solve for, and our b is going to be our beginning value. So n of t, or g of t if you're following my notation, is equal to 4.5 x, or t, 4.5 t plus 39. Okay, so now moving on to problem 2, we have the cost of Y yearbooks in D dollars, where D is a function of X. So we have D of X. The average rate of change is constant, $15 per yearbook. And we know that N yearbooks, so D of N is equal to 2,000. So now, since the rate of change is $15 per yearbook, if we add one yearbook, D of N plus 1, we're going to get 2,000 plus our rate of change of one yearbook, which we know is $15 per yearbook. So our answer here is going to be $2,015. So now moving on to number 3, we are going to find the equation of the secant line that passes through f of x is equal to negative 1/2 x minus 2 squared plus 1 at x is equal to 2 and x is equal to 4. So we know m is equal to y2 minus y1 divided by x2 minus x1. And to start, we have x2, we know that's 4. We have x1, we know that's 2. So to find our y's, we're going to plug this in. So we have f of 4 is equal to negative 1/2 x minus 2, 4 minus 2 squared plus 1. 4 minus 2 squared is just 2. Squared is 4, so that'll be negative 4/2 plus 1, which just gets us negative 1. For f of 2, we'll get negative 1/2 times 2 minus 2 squared plus 1, which is just going to get us 1. Now we're going to go ahead and plug this in. So we have y2, which is negative 1, minus y1, 1, divided by x2, 4, minus x1, 2. So that gets us negative 1. Now we're going to solve for the secant line. So we know y is equal to mx plus b. We're going to plug in our known values. So let's go ahead and use 1 and 2. So 1 is equal to m, which is negative 1, times 2x plus b. Negative 1 times 2 gets us a negative 2. When we go ahead and add that over, we get 3 is equal to b. So y is equal to negative 1x plus 3. So for y equals mx plus b, we're on number 4. We know for a that m needs to be greater than 0, which means for a, the slope must be positive. Then b must be less than 0, so our y-intercept must be negative. So any of these where the slope is positive and the y-intercept is negative, you can see that here C will work because the y-intercept's negative and it's going upwards. So for B, we know the slope is less than 0, which means the slope is negative. And the y-intercept is greater than 0. So our y-intercept is positive, and the only one of those that matches that is going to be A, because we start positive and then we go down. So now for C, sorry, the answer to the last one was A. Now for C, we have that the slope is less than 0, so the slope's negative, and our y-intercept is also less than 0, negative. So here, the only one that works is B, or D, sorry, because we're going down. So the answer to this one's going to be D. All right, and on to number 5. So exponential functions. We know for decay, our formula is going to be our initial value 1 minus r to the t. So for number A, letter A, median home prices were about 186,000 at the end of 2008 and fell by about 2.5% per year for a few years. Let M be the median home price and T be the number of years since 2008. So we're going to write out M of T is equal to P, which is our initial value, 186,000, times 1 minus the rate, so 0.025 to the T, which is equal to 186 times 0.975 to the T. Now we're doing B. So for growth, the negative sign in the last equation turns into a positive sign. So we have P times 1 plus R to the T. So now we have Dan had an annual salary of $40,000 when he was hired, and he had an annual salary increase of 3.2% each year since. Let D be Dan's annual salary and T the number of years. Here we have D of T is equal to P, so 40,000, times 1 plus the rate, 1 plus 0.032 to the T. So this is equal to 40,000 times 1.032 to the T. So now we have our third type of exponential functions, which is continuous growth, which is going to be P E times R T. So for this next one, we have 1 million bacteria, so that's P, times E to the rate, so 0.086 times T. So now for letter D, right here, we have 100 milligrams of radioactive tritium, and it was decaying at a continuous yearly rate, so continuous, of 5.63. Let R be the amount in T years. So R of T is equal to PE, and this time, since it's increasing, it's going to be negative RT. So our P is 100, our E is negative 0.0563 T. So E, we really need to think about here because it's on here a little bit as a trick. So the cost of Ray's auto insurance was $400 in 2020 and has been increasing by $50 per year since that time. Let I be the insurance cost at time T years. So here, it actually is just a linear function because we're increasing by $50 a year. Notice how nothing in here says rate, versus the other four all talk about a rate or a percentage. This one is linear. Okay, number 6. The population of India was about 1.45 billion people in 2024 and was growing at a rate of about 0.9% per year. So this is per year and not continuous. So we're going to use our P times 1 plus R to the T equation. Our P here is 1.45 in billions. 1 plus R is going to be 1.009. Make sure you pay attention to decimals. To the T. So now for part A, we have write a formula for the population P of India in billions as a function of T years since 2024. Look, we already did that. So this is equal to P of T. Not to get confused with this P, which is initial value. Okay, next. So now we have B. The growth rate stays constant, so it doesn't change. Predict the population of India in the year 2027. Round to 2 decimals. So here, the tricky part is knowing what to use for T. So since T is starting at years since 2024, for 2027, we're actually only going to use 3. So we're going to have P of 3 is equal to 1.45 times 1.009 to the 3, which is equal to 1.49 billion people. Okay, moving on to part C. By what percent should the population of India increase in the 3-year period between 2024 and 2027? So we're going to use our percent change formula. So percent change. And here we're going to do population in 2027, which we have, minus the population in 2024, or our initial, divided by the original population in 2024, which gets us 2.72%. Next is number 7. So an investment decreases in value by 5.3% each year for 3 years. By what percentage does the investment decrease over the 3-year period? Round your percentage to 2 decimals. So for our initial, we have just our I. For our future one in 3 years, we have I times the rate. So 1 minus 0.053, because we're decreasing, to the third. So it's going to be I times 1 minus 0.053, which is 0.947 to the third, 0.84927. So now using our same formula, I final minus I initial divided by I initial, we get I times 0.84927 minus I divided by I. So we can cross out all of these I's, and we're going to get 0.84927 minus 1, which is going to be equal to negative 15%. Okay, number 8. Which function has the largest a value? So we have y is equal to a b to the t. So our a value we know is our initial value. So when t is equal to 0, a b to the 0, that's just equal to a. So the one with the largest a is going to be number b, because it's the highest when t is equal to 0. So now for which two functions have the same a value, it's going to be whoever's are equal on the axis. So if we look right here, c and a are equal. So c's a is equal to a's a. So now for our next one, we have when is b between 0 and 1. So if b is between 0 and 1, that means that it's decreasing, which means the slope goes down. So this is going to be numbers a and b. So this guy is a and b. So now for b values that are greater than 1, that means that it's an increasing function. So our answers for our increasing ones are going to be c and d. Next we have number 9. A sample of rock was found to contain a mixture of minerals, part of which were radioactive and decreasing over time due to decay. The mass m of the rock in grams after 2 years was given by m of t is equal to 15 plus 3.8 times 0.785 to the t. What is the equation of the horizontal asymptote? So this equation gets raised 15, and the original equation will look something like this, with the asymptote being 0. But for this equation, we raise it up 15, so our asymptote ends up being at 15. So here, our horizontal asymptote is y is equal to 15. Next, our initial value is going to be when t is equal to 0. So m of 0 is equal to 15 plus 3.8 times 0.785 to the 0. This term here is just equal to 1. So we have 15 plus 3.8, which is 18.8 grams. So next it wants to know what should the mass of the rock eventually approach as time approaches infinity. So this here is the same as my asymptote. This is going to be 15 because our horizontal asymptote is 15. It can't go lower than 15. So as t gets really, really large, it goes to 15 grams.
Okay, next we need to start with the graph 2 to the x and then write a function based off the transformations. So for a, we're going to reflect across the y-axis, stretch vertically by a factor of 3, and shift up 1 unit. Okay, so vertically by a factor of 3, that's going to go on the outside. And then I'm going to have times my 2. When I reflect across the y-axis, that's going to go on the inside of my function. And then the last thing that happens is we shift up 1 unit. So that's going to go completely outside plus 1. All right, and that should be our function. Okay, now we're going to do the same thing, but now our function is going to reflect across the x-axis, compress horizontally by a factor of 1 over 3, and shift right 1 unit. So then we're going to have f of x. Since we are reflecting across the x-axis, we're going to have a negative out front. And then since we're compressing horizontally by a factor of 1 over 3, We know that 1 over 3 should equal 1 over b, so our b here is going to be 3. So in front of everything, I'll have 3. And then we also know that we're shifting right, so this should give me x minus 1 up in the exponent. All right, and that is our answer. Okay, so suppose a population of ants in a colony grows at a continuous rate of 6.2% per month, and the initial population of ants was 200,000, and we need to first write a formula for the population P of the colony at the time t months. Okay, so we know our formula should be something like P of t equals P naught e to the kt, where P naught is our initial value and k is our continuous rate. Expressed as a decimal, so now we just need to fill in the pieces. So P of t, our P naught, our initial value is this 200,000. And then we have times e to the 0.062 t, and that is it. Okay, and then what is the monthly percentage growth rate? Okay, and now we need to find the monthly percentage growth rate, so we can use the formula new minus old over old times 100 to find this rate. And so what are this new and old values? Well, I'll take the old value to be the initial value of my population, and maybe my new value will just be 1 month after, so when t equals 1. Okay, so we'll go ahead and compute that, and that should be 200,000 e to the 0.062 minus 200,000, because that's our initial value, and then all over 200,000 times 100. Okay, and then we can plug that into our calculator, and that should give us 6.396% as our monthly percentage growth rate.